Hi everybody, Mr. Nichols here, and I'd like to spend some time talking about graphing of constant motion, position time graphs, and the information you can extract from a position time graph, namely displacement, distance, average velocity, and average speed. The thing you want to keep in mind looking at any graph of motion is that we're always going to plot time on the x or horizontal axis. And the vertical axis or y-axis is going to be a particular value. In this case, we're going to look at an object's position. Now, position is a very specific term when we look at it in physics. And in that position indicates not only how far away you are from a 0 point, but also in what direction. Because if we are looking at linear motion, we can have an object moving in a line and travel either north or south, east or west, backwards or forwards, left or right. So you can be 20 meters north or 20 meters south. The 20 meters tells you how far away you are from an origin, but the north or south locks your location in. So directionality is really important here. The graph I'm looking at on this page, if we start and say that the blue line indicates the motion of this object as it moves over a 55-second time span, notice that the object starts at a position of 0 at time 0. That would correspond to an object being right on the number line here at 0, 0, and that's the starting point. As time goes on, this object is moving in the positive direction, so I'm going to show it moving to the right here. And don't take it this is lining up with the graph below. I'm kind of exaggerating the motion here. So for 10 seconds, it's going to keep moving. Now 10 to 15, it doesn't move, so it's just hanging out here for 5 seconds. Now notice what happens. For the first 10 seconds, we moved a total of 60 meters in the positive direction away from the origin. We pause for 5 seconds, our position doesn't change. Now from 15 seconds to 30 seconds, look at what happens. On the blue line here on the position time graph, we are seeing that we are moving closer and closer towards the origin again. So our position is getting less and less from 60. We're at 50, 40, 30, 20, 10, 0. So that would be shown on the little number line above as such. At 15 seconds, and then 20 seconds, 25, 30, 35, boom, 40. So we move this way, we pause, we move back. So think of this motion down here is relating the motion as time goes on. If we want to look at how an object changes its position over time, because we're looking at motion, so moving objects, we come up with another term that we use called displacement. And the displacement is the change in the object's position as measured over a span of time. And what this is going to mean is you're going to measure the displacement between two time measurements. And if we look at the first question here, what is the object's displacement from 0 to 20? So they're asking you, if you look at 20 seconds, how does the position of that object at that point in time compare to its starting position, its initial? The two time markers here give you your initial and final values. So the position this thing has at 0 is your initial position. The position it has at 20 is your final position. Final being the last point in time we're looking at, the initial being the first point in time. So I've labeled them up here on the graph, noticing that I just direct reading up from 20 to there, and then at 0, I'm at 0. So the displacement equation would tell us that if we take x final minus x initial, we will get the overall displacement of this object. We're located at a final position of 40 meters. We start at 0 meters. So we have displaced 40 meters in the positive direction from where we started. Don't get confused by the fact that these 2 points here at 0 and at 20 don't occur on the curve. That's not necessary. Between any 2 points, we just want to know how far apart is the object between its final and initial position that they're asking you about. Another example that we can do quickly here is, what is the displacement from 10 to 40 seconds? Let's clean this up again. Well, let's take a look at this. This is my initial, and that's my final. So what's my initial position? Well, 10 seconds, my x initial is up here now at 60 meters. My final position occurs at 40 seconds, which will be down here. That's my x final. And so using the same equation, my final is minus 40 because it's 40 meters negative. So it's 40 meters to the left, for example. And we're going to take away from that. So the minus is part of the displacement equation. It's not tied to the numbers. And our initial position is 60, if I'm looking at this right, from 10 to 40. So minus 40, minus 60. Now this is going to give us negative 100 meters. Now that's going to seem strange, but remember, this is saying how far is the object located finally from where it started. So we've had a shift of 100 meters in the negative direction, or to the left from where we started. And that's what that's saying. So every displacement is always relative to your starting point. So relative to 60, if we're negative 40, we've moved 100 negative to get to that value. Distance is the way most of you learned how to measure things. Meter sticks, tape measures, odometers on cars, they only measure stuff. There's no positive or negative to them. So when you're doing a measurement, distance is just total. How much have you moved in total? And what that's going to mean is, when I talk about the distance, it's the sum of, I wrote that twice, of the absolute value of the displacements. And I'm going to show you what I mean by that. If we look at the back and forth motion, so how much distance does it travel over the entire motion? Well, let's take a look at that. Entire motion means the entire graph. And what I want you to follow along with me now is how I kind of label this. I'm going to label this in terms of segments of motion. I'm just going to pick, kind of crudely there, sorry. I'm going to kind of pick these frames here from, say, 0 to 10, 10 to 15, 15 to 40, and then 40 to 55. Well, I'm just going to look at the values here. This has a displacement of 60 meters. This is a displacement of 0. Now notice this one. We did this one together. This is negative 100 meters. That we go from here down to there. And this displacement back here is 40 meters. Now I want the absolute value of all these measurements, because I don't care which way we're going, just how much have we traveled in total. So if you look at the totals here, we've moved 60, we've moved 100, the absolute value, we don't need the negative, and we moved 40. So this is going to total 200 meters of total measurement, of total measured motion. So 200 meters would be the answer to that. Notice how they're different as far as the values. If, in contrast, I said, hey, what is the displacement of the entire motion? Let's take a look at that. Displacement is easy. Displacement is just, where are you ending, where are you starting, what's the answer? Well, entire motion means we start at 0 seconds, and then the final displacement is where we end up. Well, guess what? We're back at our starting point because we're back on 0, so there's no displacement there. So we move back and forth, and we ended up back where we started. So notice two different answers. Entire motion gives you a displacement, a change in location of 0, but you went back and forth the sum total of 200 meters as you did that. On a position time graph, if you want to figure out average velocity, the average velocity is given or defined as the displacement divided by the time, or the change in position divided by time. So delta x over delta t. So we need to know what is the displacement that occurred from 0 to 20 seconds. The change in time, it's 20 seconds. We go from 20 to 0, so 20 minus 0, as far as the math goes, 20 minus 0. Well, what is the displacement from 0 to 20? Well, we did that. From 0 to 20, we got this answer up here. We have 40 meters. So if we come back down here and we put in the 40 meters here, the average velocity is just 2 meters per second. So it's the displacement divided by time. If I want the average velocity from 0 to 40, we're going to come back and use the same equation again. But this time, you weren't asked to do 0 to 40 displacement, so we got to look at that. The time is going to be easy. It's 40 minus 0 for seconds. Let's look at that displacement from 0 to 40 and knock that out pretty quick here. Well, let's use a different color. That's our x final. And this is our x initial again. So look at what happens. Final minus initial. I can write it right in here. Negative 40 minus 0. Which reduces down to negative 1 meter over 1 second. So negative 1 meter per second. And that's how you do average velocity. Average speed, I'll cover that in more detail in class, but I want you to get to look at how you use distance, displacement, and average velocity on a position time graph. I hope this helped out. That's it for now. Bye-bye.